Hey guys, welcome to Algo Forces. So today we'll be moving ahead with Leetcode problem 1769, that is minimum number of operations to move all balls to each box. So it is saying that you are given n boxes and a binary string which says that at box I it is either 0 or 1. 0 means the box is empty and 1 means it contains one ball. Now, what you have to do is in one operation, you can move one ball from a box to an adjacent box I such that absolute of I minus j equals to 1. That is, it is the adjacent box, right? Because the difference between the positions is 1. And it is also saying that return an array of size n where array of 5 is the minimum number of operations needed to move all the balls to the ith box. Okay, so let's say we are at index 0. So what it wants is we have to move all the boxes to index 0 and we have to count the number of operations needed. Okay. So, and similarly, if I'm on index 1, then I have to move all the boxes before index 1 to index 1 and after index 1 to index 1. And again, we have to count the number of operations. So, if you see the answer of this, it is 113. At index 0, it is one operation because we are shifting from index 1 to index 0. Similarly, at index 1, it is 1 because we are moving one ball from index 0 to index 1, and similarly at index 3 it is 3 because we have to move one ball from index 1 to index 2 and one ball from index 0 to index 1 and then index 1 to index 2, right? So now let's try to go ahead with the approach. Okay, so what will be the brute force way to approach this solution? So let's say I am on index 1. So what I'll do is I'll just check for all the indexes after index 1. That is, I'll check for index 2, 3, 4, 5. I'll check for index 5 and I'll take the difference. That is, what will be the number of operations to move this ball from index 5 to index 1. So that would be 5 minus 1, that is 4 operations, right? I'll move it here, 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 and then here. So similarly, I'll do it for this one. Similarly, I'll do it for this one, and I'll add up all the operations required for all the indexes. And but that would be order of n square, right? Because we are traversing the array twice. And so basically, first I'll check for all the right balls, and then I'll check for all the left balls, right? And yeah, so this will give you time limit exceeded for sure because it is n square complexity. Okay, so now what other thing we can do is here is, so okay, so we have to solve this problem in less than order of n square time complexity. So can we store some of the computations, that is in this case, can I store the number of operations needed to shift all the elements from the right to a current index, and then I'll do some similar for moving all the balls from left to the current index, and can I just add them? Okay, let me show you this way. So basically now we are trying to compute, let's make it right array. Okay, so now I'm calculating the number of operations needed to move a ball at I plus 1th index to ith index. So what is the operation needed here? 0, right? Because there is nothing after this. Now what is the operation needed here? I'll also maintain one count, right? So this will give me the count at at a particular index. So what is the number of operations needed for moving one ball from I plus 1th index to ith index? So it would be 1, right? So it would be 1, and now the count becomes 2 because there are two balls now. Okay, so again I'm on index 3. So the total number of operations needed here is, see, there is one operation already there for moving at from moving this ball to this ball. Now again there are two balls here, so I need two operations, right, for moving both the balls from this index to this index. So in total it would be 2 plus 1, that is 3 operations, and the count will again become 2. Okay, so at this index it would be 3 plus 2, 5 number of operations, right? Because we saw already two operations are needed for moving till so yes, so already three operations are actually needed for moving all the balls from this index to this index, and now at this index there are two balls, so I'll need to move them too. So in totality there are five operations needed, and the count becomes three now. Okay, so now similarly at this index there will be total eight operations needed, and the count becomes three again, and here there will be total 11 operations needed. So basically if we are doing the operations needed at I plus 1th index plus count at the particular index. Again count here is 3. Okay, so what again one thing is left, that we have considered here all the operations needed for moving from right to left. Now again we have to consider from left to right, right? So I'll again maintain one another array, and there is one count. Okay, so initially there are zero operations needed, and the count is also zero. Okay, now again at index 1 there are zero operations needed because there are no balls, and count is also zero. Now at index 2, so here again zero operations are needed but the count is 1. Now at index 3, so there is one ball, so I'll need one operation, and the count becomes 0. Sorry, count becomes 1. Okay, now at index 4 there are two operations needed because there is one ball which has to be shifted from this to this, and one operation needed for shifting this to this, and again the count becomes 2, and for here the number of operations are 4 and count becomes 3. So in total what are the number of operations needed? So 4 plus, so that is left plus right, 4 plus 0 is 4, 2 plus 1 is 3, 3 plus 1 is 4, 5 plus 0 is 5, then 8 plus 0 is 8, then 11 plus 0 is 11. So that is our answer. You can cross check it with the answer given in the example. And this is how basically we'll try to solve this solution, and this would be taking order of n time complexity and order of n space complexity. Order of n space complexity. Okay, now let's move to the coding part. Okay, so what all do we need here? We need a count. We need a count array boxes dot length. Okay, then we need a left operations array. Left ops equals to new integer boxes dot length. Then similarly, I'll need a right ops array, and I can reuse count for both calculating left ops and right ops, and I will return this count as the answer. We can just override the count itself. Okay, now I'll just move from left to right. I'll start from 1, and I'll initialize left ops. Sorry, I'll initialize the count at 0 equals to boxes dot character at 0, and this is character, so I have to convert it into integer, so I'll do minus 0, so this will give me 1. I less than boxes dot length and I plus plus. Okay, now left ops at 1 equals to left ops at 0, that is I minus 1, plus count at I minus 1. Okay, okay, because we have to move I minus 1 boxes from I minus 1 to I, and that will take left ops number of operations, and there is again we have to also consider the number of operations needed before I minus 1. So this is how this formula became. And okay, and we have to also update the count variable equals to count at I minus 1 plus boxes dot character at I minus 0. Okay, and this we have done for left. Let me just copy paste. I'll just change this one. boxes dot length minus 1 minus 2 instead. I just initialize right tops, sorry, count at boxes dot length minus 1 equals to boxes dot character at boxes dot length minus 1 minus 0 for converting it to integer, and I'll go till I is greater than equal to 0 and I minus minus. So here right tops of I becomes right tops I plus 1 because we are moving from right to left, and count of I plus 1 and count of I equals to count of I plus 1 plus boxes dot character at I minus 0. Okay, now final thing, we just have to add it up. Equals to 0, I less than boxes dot length and I plus plus. So count of I, I'm just overriding it, left tops of I plus right tops of I, and I'll just return count. Okay, just let's just see if there is any compile time errors or not. Okay, fine. So let's try to run this. Mm, okay, see, so this is working fine, and let me try to submit this. Okay, so this worked fine. So I hope you got this solution, and if you have any doubts, then please comment in the comment section. And I hope you like and subscribe this video. Okay, then bye bye.